Hi, welcome back to video class 3. In my last video class, we have discussed the problems which are pertaining to n jobs with two machines, and also we have solved in that the total elapsed time or total run time along with idle time for the particular machines using Johnson's rule. See, one thing you have to remember is that the Johnson's rules will be only meant for formation of sequence order, that too only for n jobs with two machines. If it is occurring three machines, four machines, means that we need to convert into particular number of machines into two machines. For example, here in this video class you are going to solve the problem pertaining to n jobs with three machines. Now you are going to come across the problem of three machines. Now that three machines will be going to be converted into two machines. Then you are going to apply Johnson's rules. Then you are going to get a sequence order. Once you got a sequence order, again you are going to solve for the calculation of total run time along with idle time for the each particular machines. Okay, let us solve the problem using Johnson's rule for the formation of sequence. Just look at the problem now. Just I am going to read out the problem statement. There are 5 jobs, each of which has to be processed through 3 machines A, B, C in the order of A, B, C only, and the processing time he has given in terms of hours. Okay, the 3 machines he has given A, B, C. One thing just you have to remember, be careful that he has given in the order of A, B, C. See, there may be chances of changing the order also in the question paper. Just last year they have asked, instead of asking A, B, C, they have interchanged, like means they have asked CBA. They have asked, for example, last year I saw the question paper, there they have asked CBA. In that situation, you need to, again you have to create the table. You change the machine order as CBA, like that. Whatever the order they are given, same order you need to take now. Understood? That's why while reading the problem, just be careful. Don't take as a sequence order. If it is now you are in the problem they are given order A, B, C, just that's why I have done A, B, C only. If the order is B, C, A, you start B first, C second, A last, like that. Okay. Now they are given, and everything, the processing times also given for the particular jobs in terms of hours they are given, and also we need to calculate optimum sequence order for the particular jobs along with minimum run time or elapsed time along with idle time for the particular machines. How to convert your three machines problem into two machines? For that we have two conditions. If any one of the condition is satisfied, then you are going to create three machines into two machines. What are those two conditions? Let's see now. If minimum value of a machine, just look at a machine with respect to all the jobs. What is the minimum value there? 3 is our minimum value, that is pertaining to first job. Okay, that's what I have written. Minimum a value is 3. If it is greater than or equal to maximum value of B machine, what is the maximum value of B machine? That is 5. That is pertaining to second job. Yes or no? Let us see whether the condition is satisfying or not. Nothing but 3 is greater than or equal to 5. No, it is not satisfied. Then go for next condition. What is the next condition says? If minimum value of C machine, the minimum value of C machine is what? 5. That is pertaining to 3 job. The minimum value of C machine is 5. Okay, if it is greater than maximum value of B machine, what is the maximum of B machine? 5. I have written. Now the condition is satisfying. 5 is equal to 5. That is, condition is satisfying. Now you are going to creating two jobs. By how you are going to creating two jobs? Let us, I will call two machines. New created jobs are two machines. That is called G and H. In G machine is nothing but you are going to adding two machines. Those are A plus B is equal to consider as a one machine, and remaining B and C as a remaining one machine. Now we have created two machines. Those created machines are, let us call as a G and H. G is a combination of A plus B and H is a combination of B plus C. Now we need to add all the processing time which are belongs to particular job. For example, see here, for particular job 1, 3 is the processing time initially, and processing time of B is what? 4 hours. Now we need to add 3 plus 4 is equal to 7. Similarly for second job, in first machine 8 hours they are given processing time. For B machine 5 hours. Now we need to add 13 hours. Like that it will be added for AB for the first type machine and B and C for the second machine. See, I have created new table, that is all the added processing time of particular jobs with respect to A, B, with respect to B and C. Now you apply Johnson's rule. Now you have created two machines G and H, and now you apply Johnson's rule for the getting sequence order. What is the first step for following Johnson's rule? First step says that before going to scheduling, find out the least processing time. Least processing time. If suppose if the processing time is tie, nothing but if the two machine or three machines having same processing time, then you choose arbitrarily. As you wish, you can choose any one of that. Let me search for first least processing time. In my table, the least processing time is 6. Obviously, that is third job on machine B. On machine, I can call H as a M2 and G as a M1 machine. Okay. Now your least processing time is available on machine 2 or H machine, that to third job. That is processing time for third job. Okay. This is the first step. How to alert now? If the processing second step of the Johnson's rule says that if the processing time, if it is available on first machine, here my first machine is G, if the processing time is available on first machine, that we need to alert immediate as early as possible. Nothing but you need to alert that particular job from immediate left to the right. Suppose if the least processing time is available on machine 2, we need to alert that particular job as late as possible. It means immediately start with right to the left. My processing time, least processing time is available on machine 2, that to H machine, nothing but machine 2. So we need to alert that particular job as late as possible, nothing but from right to the left. That's why I have written 3. If it is first, you need to write for left, immediate left to the right. Now I alerted. Once you are alerted, third step of Johnson's rule says that once you alerted the particular job, that erase that particular job. No need to consider for further scheduling process. Now 3 is over. Remaining you have only 4 now. Now go for searching for the after 6. What is the least value? 7 hours. Now here tie back is there. 7 hours will be situating for first machine, obviously, that too for 3 jobs 1, 4, 5. Now at that time the Johnson's rule in the first step says that you choose arbitrarily. That's why I choose first as a preference I given for the first job. That's why if it is on first machine, we need to start immediately as early as possible. Nothing but from left to the right. That's why I have written first. Next 7. Again 7 is available on which machine? Fourth, same machine only with fourth job. That's why I have written fourth. Again that erase now one job, fourth job along with third job. Remaining is now 5, 2. Again least value in that 7. Again just you alert starting from again 1 is completed, 4 slot is completed. Again you need to add 5th now. The remaining gap is what? You need to fill 2. Okay. See, this is my sequence order you obtain from Johnson's rule. Again, don't think that only this is the fixed order. Again, see here, if you go for other options also, you need, again you got 3 more options for getting sequence order. Those are, you can go for 4, 1, 5, 2, 3 or 5, 1, 4, 2, 3 other sequence orders. 4Y 1, 2, 3, 5, 4, 1, 2, 3. These are the others options of getting sequence order using Johnson's rule. If you use any one of these sequence order, the answer you're going to get is common. Understood? Now, this is the first question they are asked in the problem. Formation of sequence order for the 5 jobs. Now the first question answer is already given. Next is what we need to calculate now. Elapsed time along with ideal time for the machines now. Now go for the next table. See, one thing you have to remember that Johnson's rule only meant for getting sequence order. Now, as usually, as I discussed in the problem of the last video class problem, how to calculate elapsed time and how to calculate ideal time. Now you have to write the original table they are given as for the problem. Okay. Now you create one more table, that is job sequence. Now you got job sequence I have taken as a 1, 4, 5, 2, 3 I have taken. As you wish you to take, you have 4 options, 5 options are there. as you wish you take in the job sequence order. And you write machine A, machine B, machine C, and in that you create the table in time, out time, nothing but starting time, finishing time or ending time for the all the machines. Now this is what you have done in the last previous video class. Okay, now job, see our sequence order you got from Johnson rule is 1 4 5 2 3. Okay, first job will going to performing on first machines. All the jobs first, how many jobs are there? 5 jobs. All the 5 jobs need to be performed on the machine 1, then only that will be shifted to B and C respectively. Okay, now first job, obviously first job starting time will be 0, obviously. Okay, and in A machine how much time it is going to processing? Just look at the table, original table, 3 hours. That's why 0 plus 3 is equal to 3 hours, nothing but after 3 hours only the job 1 will going to comes out, and that will going to be introduced into the machine B. Okay, next fourth job is there. Now fourth job is what? And fourth job will immediately after completion of 3 hours, the fourth will be introduced into a machine A. Nothing but 3 hours becomes starting time for the fourth hour, because it has to wait for until completion of the first job. 3 hours becomes now starting time for that. Okay, how much duration it is going to processing on machine A? Now just look at the original table, fourth on machine is 5 hours, that is 5 hours. You need to add 3 plus 5, 3 plus 5, that is 8 hours. Okay, 8 hours. After 8 hours only the fourth job will be comes out from the machine A. Next fifth job again, after completion of 1 and fourth job, the fifth going to be introduced into a machine A. Nothing but it has to wait 8 hours. It doesn't mean that waiting is doesn't mean that idle time for the machine A, because it is continuously or sequence order only, it is processing on machine A only, but idle times will be always available on B and C remaining machines, because that has to be finished, then only until that B, 2 machines here, B and C will going to be waiting for that. Those are called waiting, those are called idle time. Now fifth job will be introduced to machine A after completion of 8 hours. That becomes the starting time for the fifth job. Now how much time it is going to be performing on machine A? Just you go for fifth, that to 4 hours performing on machine A. That is called 8 plus 4 is equal to 12 hours. 12 hours. After 12 hours only fifth will going to be comes out from machine A. Next second job. The second job after 12 hours only it will be introduced into a machine A. And how much time it is going to performing on machine A? Just to observe, second job with respect to machine A, 8 hours. The processing time is 8 hours. 12 plus 8 is equal to what? 20 hours. Last job is what now? Third job. Third job has to wait 20 hours. Its term is what? After 20 hours it is going to introduce into a machine A, and its processing time is what? Third hour, see 7 hours it is going to performing on machine A. Total how much time? That is 20 plus 7, nothing but 27 hours. After 27th hour only 3 will be comes out from machine A, and that will be shifted on machine B. This 27 is nothing but total elapsed time of the machine A. All the jobs will going to be completed after 27 hours. After 27 hours all the jobs will going to be processing on machine A. Now come for machine B. Now machine B, see after 3 hours only the job 1 will be comes out from the machine A. Until that the machine B has to wait. See here, B and C always machine A doesn't have idle time. B are remaining C, except A remaining machines will going to have idle times. Okay, and see here, for receiving the first job for the machine B, it has to wait for 3 hours. That is called idle time. Idle time nothing but what? There is no operation performing on B machine or any particular machines. There is no any job for performing the operations. That 3 hours becomes starting time there. In nothing but starting time or nothing but finishing time. Okay, that particular job, how much duration is going to processing on machine B? Which job? First job 4 hours. That's why 3 plus 4 is equal to 7 hours. After 7 hours only the first job will going to be comes out from machine B. Next fourth job. Just you observe here, be careful here while solving the problem. Just importance must be given to out times of all the machines. Out times are very much important. Just here in that out times you need to remember. Similarly out times you have to, based on that you have to create the out times. Here 8 hours, 8 hours are there. Here which one? Fourth job here. Now we go for fourth job. After 8 hours only the fourth job is going to comes out from machine A. Now see here, look at this next second job which is going to be processed on machine B is fourth job. See here, the first job is already completed in machine B after 7th hour only. I cannot write 7th hour as a in time for the fourth job because in 7th hour it is still processing on machine A. I cannot write as a 7 for the starting period. After completion of 8th hour only it is going to come for machine B. Yes or no? That's why just now I told, just look after the out times of machine A before writing your starting time for the machine B. Now 8, which is the greater among this one? Nothing but after completion of 8 hours only it will going to introduce into a machine B. That's why you need to write, instead of 7 you need to write 8. Nothing but, even though the object, nothing but job 1 is completed in 7th hour, the machine B has to wait for 1 hour for receiving your fourth job for a particular machine B. Understood? That becomes ideal time now. Understood? Next go for 8th. Okay, I will going to write starting time as 8th hour. How much duration it is going to performing on machine B? Job 4th. Just look at here. Job 4 is 2 hours. Just look at the original table. The 2 hours that is going to performing. 8 plus 2 is equal to 10th hour. After 10th hour only, job 4 will be comes out from machine B. That will be again going for the machine C now. Next, which job is going to introduce for machine B now? 5th job now. Just look into the job now. 5th job. Okay, 5th job. How much duration? Just see how much duration here? 12 hour. After 12 hour only the machine, so nothing but 5th job will comes out from machine A. Okay, again see here, I cannot directly as 10 here because during 10th hour it is still processing on machine A. I cannot write 10th here, 10 I cannot write 10 here. So that your starting time will be how much? After completion of 12th hour only the 5th job will comes out. That will become your starting time here, not your 10th hour. Okay, now see here, till that machine B has to wait for 2 hours because 10th hour itself the fourth job is finished. Again for receiving your 5th job the machine has to wait for 2 hours again. That becomes again ideal time for that. Okay, 5th job, how much duration is processing on machine B? Just look here. 5th job, again 5th job, how much duration is going to take place? 12 plus 3. Okay, 3 hours it is going to processing on B machine. 12 plus 3 is equal to 15 now. Okay, next after 15th hour, okay, it is ready for receiving another job. Which job that is now? Second job now. Second job, see here. So second job will be comes out from the machine A after completion of 20th hour. 20th hour. But in 15th hour itself the job B is receiving for, ready for receiving your second job. But in 15th hour it is still processing on machine A now. I cannot write 15 as a starting time for machine job 2. I should write starting time for job 2 is 20 now. After 20 hours only 2 will going to receiving on machine B. That's why I have to write starting time is 20. How much time it is going to be performing on machine B is 5 hours. Just look into your original table. Third, see here, to 5 hours. Machining is 5 hours. Nothing but 20 plus 5 is equal to 25 hours. Next, last job that is going to receiving is third job for the machine B. See, when it going to comes out for machine A, after 27 hours only the B is going to receive your job. That is which job? Third job. But it is already see it is ready for after 25th hours the 2 will be completed. It has to wait for again 2 hours for receiving your third job. Again it will be 2 hours ideal for the machine B. Okay, that's why the machine A almost doesn't have any ideal time. The remaining machines will going to wait. That was all called as ideal times now. How much time it is? 27 hours and processing time will be 1 hour on the machine B total is 28 hours. See, this 28 hours is the total elapsed time for the all the jobs which is going to be performing on machine B now. Now go for the last machine now, which is called C machine now. C machine. C machine. So now, after completion of first job on B machine, when it's going to complete, it's going to complete on 7th hour. Till that, the machine C has to wait. After 7th hour only, it will going to receiving from B machine. Which job? First job. Nothing but in order to perform first job on machine C, the machine C has to wait for 7 hours. That will become starting time along with your ideal time for the C also. Okay. Now, first job, how much duration it going to performing in machine C? 7 hours. 7 plus 7 is equal to 14 hours. Okay. Now just look at the out times of machine B. It is 10. It is 14. Okay. Least value is there. Which is greater value? 14th is the greater value. That becomes starting time for the particular remaining job. Now, the 14th hour become the starting time for the job 4. That will going to performing on machine C. How much duration now? For the 6 hours on machine C. 6 hours on machine C. That will become 20 hours. 20 is now starting time. Just look at the output time of machine B for particular job. Which job? Fifth job is 15 here. Here 15, 20 is there. Maximum is 20 you have to write. 20 hours plus how much duration that is going to performing on machine B? 10 hours. 20 plus 10 is equal to 30 hours. Now 30 hours, once 30 hours is completed, job 5th will be comes out from machine A. Okay. Now, which job is ready for receiving now? Second job. So after 25th hours it is completed. Now how much hours? 30 hours. Look at the output time of machine B. Particular job is 2 hours, 25th hour. What is the maximum here? 30. 30 you need to write as starting time for receiving your second job on particular machine, that is C machine. How much duration is going to performing now? 9th hour. 9 hours. 30 plus 9 is equal to 39 hours. 39 hours will be there now. Now, last job that is going to be receiving when after completion of 39 hours only on that machine C, then it is going to receive your third job. How much time it is going to performing on machine C? 5 hours. Just look at the original table. 5 hours will be there. 5 hours will be there. 39 5 is equal to 44 hours. This 44 hours is called as a total run time on the machine. Total minimum elapsed time is what? Total 44 hours are required to performing all the jobs in machine 1, 2, 3. That's why 44 is called as a minimum elapsed time or total run time or the machines. This is the second question they asked in the problem. Now ideal time for the machines now. Ideal time for the machines. Very easy for this one. How much total time now? Elapsed time. I told total run time is equal to what now? 44 hours. Okay. Here just machine A. You will go for machine A. How much ideal time now? See, after completion of machine C, 44 hours. Suppose if you want to receive any job, how much duration it has to sit for idle? 44 minus 27. It's about 17 hours it has to idle. For a particular job has to comes out now. Similarly, you go for machine B. There is no idle time here. That's why I not taken idle time here. Then 44 is the total elapsed time here minus 28 hours for the total duration that is going to processing, plus these are called ideal times that you need to subtract from the total run time. That will going to give us 29 hours. Nothing but how you got 29 hours they say here. 44 total run time minus 28 hours is the processing time for the all the jobs that need to be done on machine B, plus 3 hours is idle time, because for receiving first job on machine B, it has to wait for 3 hours. That's how 3 hours I have written. Plus, here second job will going to receive after 8 hours. Again, 8 minus 7 is equal to 1 hour. Again, 12 minus 10 is equal to 2 hours. 20 minus 15 is equal to 5 hours. 27 minus 25 is equal to 2 hours. If you subtract all this with 44, you are going to get 29 hours it has to be idle. Once it is completed its performance, all the machines, it has to wait for 29 hours. Now what is the ideal time for machine C? See, 44 minus 44. Obviously, yes or no? 44 hours is the maximum and 44 hours you got plus 7 hours is your ideal time. How? Because for receiving first job from the machine B, it has to wait for 7 hours. That is your ideal time for here. Here, for example, here output time for machine A is what? 3 hours first for the first job. That becomes ideal time here. Similarly, for receiving first job on machine C, the output time of machine B for the first job is 7. These are all ideal times. Okay, 44 minus obviously 44 will be processing time plus 7 hours is equal to your ideal time. Total ideal time is 7 hours. See, these are called ideal times of particular machine. For machine A 17 hours, because total runtime minus the processing time of particular machine is 27 hours. If you subtract, you will get ideal time. And if you go for machine B, total processing time is 44 hours minus its performance hours is 28, along with some of the ideal times that is going to be situated on machine B. See here, again one more thing I will explain again for machine C here. 44 hours minus 44 plus 7. See here, if you subtract here, 14 minus 14 0, 20 minus 20 will be 0, 30 minus 30 will be 0, 39 minus 39 will be 0. You won't get any ideal time for that, because all the processing time will be greater than your outcomes of the B machines. Okay, see, you got these are the ideal times, and this is 44 hours will be your total elapsed time for the particular jobs. See, this is how we need to calculate total elapsed time and particular elapsed time as well as particular idle time for the particular questions. Okay, again in next class I will going to explain graphical method if possible regarding the how to calculate minimum and elapsed time for the using graphical method instead of going for numerical method. Thank you.